Hello everyone, I welcome you all for my third video lecture on cash flow diagram concept. If you do remember, in our two previous videos we have understood the concepts like the basic understanding of engineering economics, the cash flow diagram, and the very important two parameters which are related to cash flow concept, that is, first one, the single payment compound amount factor, and second one as single payment present worth factor or parameter along with numerical problems. But the today's agenda will be the next two parameters of the same concept, which are called as third parameter, uniform series compound amount factor, and fourth one is uniform series present worth factor. And along with these two parameters, also we will be solving one numerical problem on each of these. So now let us start understanding the third parameter, which is called as uniform series compound amount factor. So now, to understand this parameter theoretically and practically, let me give a small example. Think that there is a person called as XYZ, and the salary of that particular person is very much less. So because of this reason, what we have to understand, or what we can understand, is at the end of each month that person's savings will be very much less. So because of this reason, what that person will do is, whatever the savings he has done in that particular 1 month, so that amount is going to be invested in one bank at various stages with a small interval of time. That means 1 month he is going to invest a certain amount. After that, second month again he is going to invest a small amount, and again in third month he is going to invest the same small amount. So like that it will be go on, and after a particular longer time duration he is going to get the amount in bulk. So this is what the meaning of the uniform series compound amount factor. But the fourth one is exactly reverse of this, which is that the fourth one is called as uniform series present worth factor. So here what we can calculate, or what this factor suggests, is if I am having a bulk amount with me, and if I am ready to invest that in a certain bank, but after investment I am not going to wait for longer period. Only with a small time interval, or only with a small gap of 1 month or 2 months, I want to have my income. So now to calculate this, whatever the parameter we have, it is called as the fourth parameter, uniform series present worth factor. I hope I made these two parameters very clear in theoretical manner. So now, to understand these two parameters in more better manner, let us consider some of the numerical problem. So now, firstly, I am going to solve one numerical problem on third parameter, which is called as uniform series compound amount factor. But before we start understanding the numerical problem, again very quickly I am going to repeat that the meaning. So here what we can calculate is, with only small amount of investment with a certain rate of interest, after a certain longer duration, how much amount I can get from the bank. This is what we are going to calculate from this method. So now let me consider a numerical problem. So here the numerical problem what we have is, if 8 annual deposits of ₹5,000 each are placed in the account at 8% interest per year, how much money will be accumulated immediately after the last deposit? So here for this numerical problem, before we start getting the solution, first let us understand what is the logic behind this numerical problem. So here with this, one thing is very clear that whatever the example we had considered during our theoretical understanding, let me continue the same example, that person XYZ. So here the savings of that person XYZ per year is 5,000 rupees. In my explanation, I had told you only for the sake of understanding per month. But here the value, this 5,000 is given per year because of many reasons. The savings of one person XYZ per year is only 5,000 rupees. So that 5,000 rupees he is going to invest in various stages. That means 1 year, that is first year 5,000 rupees, second year 5,000 rupees, third year 5,000 rupees, like that it continues up to 8 years. But for all these 8 years the interest rate is same, that is 8%. So now with this, what they have asked us to calculate is, after 8 years of deposition of 5,000 rupees with the rate of interest 8%, how much amount that person XYZ can get after 8 years. I hope I made the logic behind this numerical problem very clear. So now with this, let us start getting the solution for this numerical problem. To get the solution, here we are having one standard formula which is as follows. F is equal to A into 1 plus I raised to n minus 1 divided by I. This is the standard formula what we have for this method. So now here I already, we know I is nothing but my rate of interest. Again in the numerator and denominator the I parameter is there, and n means the total number of years of investment, and here A means per year investment of that particular person XYZ. So now if you substitute all these three values in the standard formula, the number what we get here is F is equal to rupees 53,183 rupees. So now after calculating this number, what is the practical meaning is, again I repeat, with the investment of 5,000 rupees yearly after 8 years with the rate of interest 8%, that person XYZ is going to get his income as 53,183 rupees. So now here our numerical problem does not end, because whatever we have calculated, that has to be represented in cash flow diagram. So here for that you please refer this diagram. So here again we are having two different types of lines. One is horizontal line and one is vertical lines. So here the horizontal line is representing the rate of interest and duration, and the vertical lines are representing my cash inflow and cash outflow. So in one of my videos already I have told you, when I deal with vertical lines, so always the upward vertical line will be representing my cash inflow and the downward vertical line will be representing my cash outflow. So that is why you can see here totally I am having 8 numbers of downward vertical lines, because for all these 8 years I am giving my money to a certain bank which is representing my expenditure. The cash is going out of my control. So that is why I am representing these investments with downward vertical line. After that, whatever the number we have calculated, it is coming to me. That means it is my cash inflow. That is why at the end I am going to represent this number with a upward vertical line. So here in this we are putting F as question mark, but after calculating this number we have to write this final answer 53,183 rupees here at this particular place instead of question mark. After this only we can say that our numerical problem get over. So this is all about the third parameter, which is called as uniform series, compound, amount, factor, the theoretical meaning and numerical problem. So with this, let us go for the second method numerical problem, that is uniform series present worth factor. So here the numerical problem what we have is how much should be deposited in a fund to provide for 8 end of years withdrawals of rupees 5,000 each. Interest rate is 8% per annum. PA means per annum. So here you can remember in my explanation I was telling you about this fourth method. The uniform series present worth factor method is exactly reverse of the third method. Again I repeat, in third method we have calculated one bulk amount after the investment of a small amount at various stages. But here what we are going to calculate is how much amount I can withdraw with a small gap of time with a huge amount of investment. So I hope you all are feeling that difference. First, here in this method I am going to invest a bulk amount. After that, without waiting for much time, with only gap of a small amount of time, I can withdraw a small amount of money. So that how much amount I have to invest first, so that yearly I am going to get a certain amount as income. That itself we are going to calculate here. So in this numerical problem, what they have given is the interest rate is again same as our previous numerical problem, that is 8%. But here one thing what they are specifying is that person XYZ wants to withdraw the 5,000 rupees every year. So now for this condition what we are supposed to calculate is to withdraw 5,000 rupees amount per year after for continuous 8 years, how much amount we have to invest today in this particular current year. So that is what we are asked to calculate here. So now to calculate this number, again we are having a standard formula which is as follows. P is equal to A into 1 plus I raised to n minus 1 divided by I into 1 plus I raised to n. So here again all the parameters are known to us. One I is, that is nothing but rate of interest 8%, which has to be substituted as 0.08, because directly we are not supposed to substitute the value in terms of percentage. And after that we know A. So what is A here? The 5,000 rupees. The withdrawal what that particular wants to have per year. Correct? So now after substituting all these given number in this standard formula, the number what we can get is 28,733 rupees. So now after calculating this number, we must understand the practical meaning of this number. So now here, what is the practical meaning? If that person wants to withdraw 5,000 rupees per year continuously for 8 years, then that person has to invest 28,733 rupees in the current year itself with the rate of interest as 8%. So again, after this our numerical problem does not over, because after calculating this number we should go for the graphical representation of cash flow diagram. So again here the same logic I am applying. You can see two different types of lines, horizontal line, vertical line, and again here the horizontal line is representing two parameters, the rate of interest and the duration, and the vertical lines, as I already explained, downward vertical line cash outflow and upward vertical line is representing my cash inflow. So here you can see this cash flow diagram is exactly reverse of my third numerical problem. So there we were having 8 vertical lines which are towards downward, but here what we are having, the same 8 lines but upward direction. Why? Because here with only one investment, that is 28,733 rupees, I am going to get my income after a year. First year I am going to get my first income, second year I am going to get my second income, third year I am going to get my third income, fourth year again I am going to get my fourth income, and here in all these 8 years the income will be fixed, that is 5,000 rupees. But to have this 5,000 rupees as my income for all these successive 8 years, then the investment should be equal to 28,733 rupees. I hope I made all the things very clear in this numerical problem. So I hope that whatever the concept we have covered today, you all have understood, and it is very clear to you all that what exactly the third and fourth parameters are. One is uniform series compound amount factor, and fourth one is uniform series present worth factor, with both theoretical understanding and numerical problem. With this, let me finish my video lecture. Thank you all for watching.